Today's job is to parse the output of Bayesian trait prediction of ancestral states on a phylogeny, output by Bayes traits, which you can see here. One issue is this is a synthesis phylogeny, so very large, and most of the internal nodes have been predicted, so it's a rather huge file, which makes it a bit awkward. Can't actually open it and show it. Now, I've parsed Bayes traits quite a lot over 10 years now, so I'm a bit surprised this doesn't work. Now, typically I'm working with prediction of states at the terminals. Now it seems this is different. I've done from the ancestral states. When you do the ancestral states, you get a bit of a different format. So that's why this has not worked. This parser is not appropriate. So I need to add a bit of code to deal with this different format to this script for parsing Bayes traits. If you want to read the output of Bayes traits in Tracer, which is a common software for looking at Bayesian chains, then normally you have to cut out part of the text file, but because the text file is so large, you can't really do this. It'll crash your text editor if you try and open this. So first thing I did is just to output the relevant columns, the Bayesian chain, into its own file, so that opens in Tracer. And looks like this doesn't really change much, so I'm not too worried about the things like burn-in for now. So one thing I should do is, I haven't depicted on here what the regular format looks like. I'll just go and retrieve an example of this. Okay, finally I found this. This is what I'm used to working with. This is the output of the Bayes traits when you predict states of terminals. Where you have, so in my case, I usually do this for query DNA barcodes. But what it gives here's the column header, and it has EST, and it has here's an OTU label, and it gives a state. So for each point in a Bayesian chain, it gives a state, and then you work out the probabilities across the chain. So when you do ancestral state reconstruction, it seems to be quite different. So instead of giving a state at each point, you get a probability for each state. So that's what I need to change. So when you come back to work on a script after some time, it's always easier if you have some annotation, you can figure out what you're doing, and there wasn't really sufficient annotation of this, so I've decided I'm adding a few notes as I do this. So in each cell of the table of the Bayesian run, and for each of these it retrieves these items, which is from the column title. So this is the column title here, and it pulls out of this the node name, internal node name, and the P, which stands for probability presumably, and within this it gives a state M, and then for the given row we have the entry. So I'm just thinking how to how to deal with this. I'll probably deviate from the other code, I think, and just if it's in this format, I'll just rearrange an output file accordingly. So for each row, which is each point in the Bayesian chain, we'll have the node, the internal node, and the state, and the cell entry will give the probability at that point in the chain. So I'll just increment. I'll make a hash of with two keys, the node ID and the state, and I'll increment according to the current probability, and also store the chain length and all node IDs and all states. I think okay, we should now have a full output. So we have the node ID and 3 states found in the data, and the row ID we have the node and the values returned for each. So these are, so I just need to recalculate these. So just divide by the number in the chain, which looks about right. Adds up to 1 lost. Okay, so job done. Oh, we see notice we have the root also, which is unknown, but anyway. So about 1,500 nodes and predicted states for all of these. So our next job will be to map these onto a phylogeny. Now, the difficulty in this is interpreting the node ID as a position on the phylogeny. I probably have to refer to the terminals derived from that node to map those. But anyway, for now, job done. We have parsed the internal node predictions from base traits.